Hi, my name is Shawn Hernan. I'm a security program manager here at Microsoft in the Security Engineering and Communications Group. I want to talk to you a little bit today about one aspect of secure design, namely attack surface reduction. We think attack surface reduction is a very important aspect of getting anything correct. It's, as far as security goes, it is one of the basic tenets of security that you might have heard of for a long time. Secure by default is one of our themes we practice in Microsoft. This slide shows you a pretty good example of the actual tangible benefit we've gotten from attack surface reduction over the years. This breaks down all the individual vulnerabilities in one of our bulletins we published in 2004, namely MS-04011. And as you can see, there's a bunch of different vulnerabilities here. And this shows the effect on each system, each of a various set of Windows systems, Windows 2000, Windows XP, and Windows Server 2003, with respect to each of the vulnerabilities referenced in this bulletin. Now, if you just look at each column, if you do nothing else and just sort of squint and look at each column in terms of the color, you can see that these vulnerabilities were much more serious on Windows 2000 than they were as compared to, say, Windows Server 2003. The Windows 2000 server column is mostly red, whereas the Windows Server 2003 column is at least, if not entirely green, at least mostly green, and Windows XP is somewhere in between. Now, part of that is because we just fixed the code. In Windows Server, between Windows Server 2003 and Windows Server 2000, we fixed about half of these vulnerabilities through proactive code fixes. In some cases, we had no reason to know that there was a vulnerability there. It was just code health issues. In other cases, we could identify it as a specific security failure. But overall, we fixed about half of the vulnerabilities. Now, if you're a glass half full kind of person or a glass half empty kind of person, you might think, well, that leaves still half of the vulnerabilities unfixed. But for those vulnerabilities that weren't fixed by Windows Server 2003, for about a third of them, we were able to add extra defenses. We turned things off. We put additional defensives in place. We were able to reduce the opportunity of an attacker to actually carry out an attack. And at the end of the day, it is that pragmatic benefit that really matters to customers and to the overall security of your systems. So if you take a look at the third vulnerability in the list there, the PCT vulnerability, for example, that was rated as a critical vulnerability in Windows 2000. It was a service that's not widely used. It's used in Internet Explorer to do secure communications, but most of our customers didn't use that service. In fact, very few of them used that service. There's no reason for that to be on by default. So that was proactively turned off by default in Windows Server 2003, and as a result, the net severity of the vulnerability, although the vulnerability is still there, is relatively low. Most of our customers don't use it. In fact, most of our customers don't enable it, and it gives large enterprises and individual users a much greater opportunity to fix their systems before intruders can actually compromise them. And for our customers that never enable this, there's no vulnerability there whatsoever. So between proactive code fixes and the additional defenses we put in place, we were able to reduce the overall vulnerability of Windows Server 2003 significantly as compared to Windows Server 2000. Now, you might think that well, one of the things that attack surface does for you is buy you a little bit of time, and that is to a certain extent true, but the horrible truth of the matter is that no matter how much effort we expend, we're never going to get code 100% correct. There's not a lot we can do to make sure we're perfect, and in fact, we're living in a very asymmetric world. As software developers, we have to be 100% correct 100% of the time. We've got to make sure that things are on a schedule, that things are localizable, that things perform well, that things have a good user experience, that things are supportable, compatible, maintainable, accessible, usable, doable, all of the things that large-scale commercial software needs to be. But intruders only need to be right once. They only need to find one hole in a system to attack it. Our goal, we're never going to be perfect, and so attack surface reduction really limits the opportunity for intruders to break into systems through holes that really provide through holes in software for which the customer might not actually use. You might also think that there's a bit of a patch window. Well, that's not That's not true at all. The patch window is, at the end of the day, it's really a joke. Maybe it was true a decade ago that customers had an opportunity to go from knowledge of a vulnerability to a patch over the course of a few weeks. But that's not true today. We know that researchers and intruders can go from no knowledge of a vulnerability whatsoever to a total working exploit, often in a matter of hours if they're skillful, or a matter of days if they're only beginning to use some of the tools that are out there. The Zotob worm showed that to be very true. The Zotob exploit came out shortly after the first knowledge of the vulnerability was made public. So we know that intruders can go from no knowledge of a code to a working exploit very quickly. Tools make it very easy to build exploit code. There are reverse engineering tools out there that will take a patch, that will take a product and give an attacker or a researcher great insight into what the fix actually was. So the patch itself that you may publish turns out to be valuable knowledge for the intruder to build an exploit. As a couple of examples, the PCT bug was detected by Halvar Flake within 30 minutes after only knowing of the vulnerability 30 minutes before. He was able to find the vulnerability, take the patch, find the vulnerability within 30 minutes. The H323 ASN.1 bug took less than 3 hours to do the same thing. Now, of course, finding the vulnerability and building an exploit are two different stories altogether. But given knowledge of the vulnerability, the Metasploit project can make it easy for intruders to build a working vulnerability. At a gross level, all you need is some knowledge of the vulnerability, some information about what characters won't survive a transform in the input parser, and you need to know what kind of exploit you want to write, and the Metasploit project will spit out shellcode that you can embed into an exploit tool, into a botnet, and have a great deal of control over what your exploit does without any particular knowledge of how to write the assembly in order to do that. So it's a very powerful tool for intruders to build working exploits, but it's also a powerful tool to convince yourself as a software developer that such an exploit really is or is not possible. In general, we would say that you shouldn't spend any time trying to decide whether or not a flaw in your software is exploitable or not. You will end up spending more cycles than it costs to fix the flaw in most cases. But if you really need some education about what the state of the art is with respect to exploitability, the Metasploit project can really give you some insight to do that. So at the end of the day, the cost for an attacker to build an attack is very low, and the cost to your customers is very high. It's a very difficult position to be in. It's a classic asymmetric position, but that's where we are. We've got to be right, and the attackers only have to be right once. Now, if you think about attack surface reduction, what you want to look at is your entry points. If you've got a threat model, the threat model should list all of the entry points, and it is the number of entry points that you want to restrict. Primarily, we're talking about network I/O and file I/O, the places where an intruder might be able to give data to your program to trigger a buffer overflow or trigger an integer overflow. Any of the vulnerabilities in your code, this is where you want to concentrate on. But attack surface and inputs to your program can take a whole variety of forms. Input can come from the environment. It can come from timing. It can come from it can come from cryptographic keys. All of the different places where an intruder can influence the behavior of your program or provide input into your program might actually be considered attack surface. And it's that you want to do. It is that attack surface that you want to reduce. So it's not necessarily about turning things off either. If something is executing by default, certainly you can turn it off by default. If it's an open socket, maybe you can make it a closed socket, something that has a greater degree of restriction on the number of people who can access it. If it's using a connectionless protocol like UDP, you might choose to use a connection-oriented protocol like TCP. That doesn't give you a lot of benefit, but it might make it one step harder for an attacker to actually produce an exploit. And in particular, it might make it several steps harder to build a reliable worm based on that. If you consider the possibility that people have restricted outbound connections on their network in particular, that might be helpful. If something is permitted anonymous access, can you require any sort of authentication and build a list of users around that? Certainly some systems need to remain anonymous or need to remain open to everybody. Typically web browsers serve pages that are available to everybody. But if you can provide some authentication, that reduces the number of people who can attack your system. If something requires user-level access, can you make it require administrative access? Are you providing an administrative function that only administrators of the machine need access to? If something's open to the internet, can you restrict it to the local subnet or to a range of IP addresses, or even better still, to a range of machines authenticated through IPsec? That can reduce the number of people who are available to attack your system. If something is running with system privileges, you can make it run with not system privileges. And certainly if something is running with weak ACLs, or if something is protected with weak ACLs, you can protect them with better ACLs. To the extent that it's possible, find every resource in your system and protect it precisely. Don't mix and match resources into similar containers. Isolate resources according to the security needs of that particular resource. Now, I've said a couple of times that you need to worry about attack surface reduction in terms of reducing the entry points into your system. What you don't want to do is consolidate a bunch of code all behind one single entry point. It's not really attack surface reduction if you take 12 functions that were running across 12 different ports and consolidate them into one function running behind one port. It's still the same amount of code. What you really need to concentrate on is the functionality in the code, reducing that functionality and reducing the number of people who can execute that functionality. So if, for example, if you support a large number of file formats, are there more or less common file formats that you might be able to turn off support for by default? If you're dealing with many, many different file formats, it's often the case that some of those file formats have gotten old, and maybe it's time to start turning support off for those file formats by default. That might put a little extra burden on your customers to turn those things on, but in general, that's a good trade-off. That's a good trade-off, because by putting a little burden on a small number of customers, you are removing the risk of having a large number of customers exposed to functionality that they're not actually using. So look for old things you can turn off. If you have sub-protocols in your protocol, maybe you can reduce or restrict some of the sub-protocols. SSL2, SSL3, TLS, PCT, there are different functions within each of those protocols that you might be able to restrict to only authorized users or turn off by default. If you've got a protocol that has a set of verbs in it, you might be able to restrict the set of verbs that are accessible to anybody. In HTTP, it probably makes a lot of sense to allow get, post, and head operations, but maybe you want to restrict access to the WebDAV functionality and restrict or limit access to the ProPatch, PropFind, delete, move, lock, all of the other functionality that comes along with WebDAV. In SMTP, maybe you have, for example, maybe you have a variety of verbs in SMTP, the hello and the extended hello verbs in SMTP. Maybe you don't need to support both of them. Maybe you do, maybe you don't. Mail, RCPT to other functions in SMTP that you might be able to turn off if you don't need to support all of them, or your customers can turn them on individually. That's certainly a good thing with respect to security. And queries in a database system, extended stored procedures and stored procedures, limit the number of people who can execute them and their ability to execute any particular stored procedure. And in any case, if you need to leave things on, if you decide that you need to leave everything on by default, it is certainly goodness to provide your customers the ability to turn functions off. if you've made the decision, you've decided that, yeah, 90% of our customers are going to use all of these functions. Maybe not all of them will use them all of the time. And having the ability to turn off one function or discrete functions, function by function, is a very useful thing in the event there is a vulnerability in your software. If you can't respond to the vulnerability to provide a complete patch in a timely fashion, maybe you can provide a solid workaround by saying disable, for example, the extended hello procedure in your SMTP server as a way to limit your access, limit the intruder's ability to exploit a vulnerability there until such time as a patch can be applied. So at least giving that level of control to your customers is a good thing. Now, in Microsoft, our customers have benefited a lot from reduced attack surface in a number of our products. In Windows XP, we now require authenticated RPC connections by default. The firewall is on by default, which has been greeted with a great deal of rejoice, I think, in terms of the security benefits it's provided to our customers, although by no means was that an entirely smooth transition. The firewall has been has worked out well for our customers. IIS 6 is now off by default in Windows Server 2003. Contrast that with IIS 5 on Windows Server on Windows 2000. Certainly, having a big set of code on by default provided some leverage that attackers could attack. Is now off by default in Windows Server 2003. It runs as a network service by default, and it only serves static files by default, all limiting the amount of code that a third party, an attacker, can execute. SQL Server 2003 XP Command Shell is off by default, and the CLR and COM are both off by default. And finally, it runs as a network service as well. And in Visual Studio 2005, the development web server is restricted to the local host only, and the SQL Server Express, which ships with Visual Studio 2005, is local host only as well. So a lot of attack surface reduction there, and these products have been very helpful for our customers from a security perspective. Now, if you look at actual worms that spread around the network, the Sasser worm affected Windows 2000 and Windows XP, but did not affect Windows 2003 because the RCP endpoint was marked as a local admin only. So that prevented or certainly significantly reduced the opportunity for an attacker to exploit that vulnerability on Windows Server 2003, even though the code flaw was still there. The Zotab worm affected Windows 2000, but did not affect Windows XP because the firewall was in place, blocking connections, and because authenticated RPC connections were required there. So at the end of the day, we think attack surface reduction is every bit as important as getting the code right. We're never going to be 100% perfect in getting the code right, so we have to attack the security problem from multiple angles. We have to attack it from a design point of view. We have to attack it from a code point of view. We have to attack it from a process point of view. And we have to attack it by reducing the opportunity of intruders to actually attack our code. So attack surface reduction is a key component to achieving secure by default. Now, when you're building a design checklist, make sure you're looking at all the aspects of your security development lifecycle. It really does apply to you. It applies to all the different developers in your organization, all the different testers in your organization, all the program managers, all the user experience professionals, all the user assistance people, your response team. It is a multi-pronged, multi-approach life cycle to making sure that your software is secure. Anybody who tells you that all you got to do to achieve security is use cryptography or use firewalls or use code scanning tools or use education or use any of the other things that we've talked about, they haven't really studied the problem entirely. SDL covers all aspects of the security development life cycle. It touches on all phases of development and is really the most effective tool you have to reducing the likelihood that you're going to ship a vulnerability. Now, Having said that, reduce your attack surface and reduce your attack surface early. Make sure that you know early in the design time what is going to be on by default and what's going to be off by default. If you are waiting late until test or close to ship to start to turn things off, you'll find that people have depended on functionality that you've made available earlier in the test cycle and have not considered the possibility that a component you provide might be off. Know what you're going to have on, reduce it early, and make sure that all the people who depend on you understand what's going to be on by default and what you're going to have and what they're going to have to do to turn on the pieces that you have chosen to leave off by default.